terms of explaining what is Maunder Minimum and how the generation of magnetic field really works, we can only have what you call somewhat descriptive statement where we don't have any quantitative statement at all. Like, for example, we don't know how weak the magnetic field strength has become. All we know is that the usual hand-waving stuff is that something nonlinear happened, which is one of the weasel words. Nonlinear dynamics, all this nonsense. Is that somehow one of the factors, like the alpha effects, which is the helical flow, or the differential rotation, is not working as vigorously as it could be. In fact, you can show, of course, how the superposing of all these different dynamo wave get collapsed and can produce this sort of north-south asymmetry, for example. That's the most obvious feature of Maunder Minimum. How we wish, for example, one of the areas that I'm very deep into now, because we found that the sun over the last 10,000 years has produced quite a lot of this minima, activity minima. We clearly identify another one that is well known. It's called the Sporal Minima. Sporal Minima happens roughly from about, I would say, 1420 to about 1530. That was showed up very clearly and discussed very extensively in my most recent talk at Doctor for Disaster Preparedness. So that video, I hope somebody will watch it, in the sense of how that phenomenon that is known on the sun, by the way, we can actually confirm that in multiple measurements, mainly through the concept of measuring radioisotope like carbon-14 in 3 rings, or measuring stuff like called beryllium-10 and even nitrate concentration in ice core, where you can show that these are all related to extremely anomalous events on the sun to be able to produce such a signature on the Earth archive. Essentially all related to how the magnetic field generation works. So we know that minima and Maunder Minima. Now we like to know, for example, a simple question: how weak is Maunder Minimum? How weak is Sporal Minimum? What is the relative difference between the two? Right? Unfortunately, we don't have a straight answer. As far as we can tell now, it's basically. And then, of course, never mind, the next question is how does that relate to the Earth phenomenon, right? And it clearly that, notice the time period, right? It's all related to the Little Ice Age phenomenon. So Little Ice Age, instead of being explained to be more volcanic eruption, could easily be comprehended and included by just the phenomenon of the sun weakening and multiple times separated by roughly 100 or 200 years, 180 years. By the way, that also feeds another phenomenon on the orbital forcing. So, in that whole quest for a comprehensive understanding, I don't think you can escape the conclusion that something about the sun has to be understood, right? I mean, clearly throughout this whole period, I mean, if you want to challenge yourself to think about the role of carbon dioxide in the system, I mean, you really cannot find it, isn't it? I mean, that's where the problem is, why this idea is not a theory. Again, I emphasize that this CO2 dangerous anthropogenic global warming idea is not a theory because it's never been falsifiable. And we all learn from the great lessons of some philosopher that if you cannot refute these things, it's not a theory. It's not even any scientific principle. It's not anything. It's just some strange ideas, pseudo-scientific ideas that crop up by somebody like Al Gore during his sleep, or I don't know, IPCC chairman. So this kind of problem needs to be cast in scientific form. This is what the work most of me and my colleagues are working on. Trying to understand, to get at, to better define this boundary condition. And of late, I realized that just the idea to try to understand how the sun and climate relation would not be complete without invoking another variable in the Earth system, which is basically how the tectonic system responds to it. In the sense that how is it related to volcanic output and even earthquake actually, because every time earthquake slip within boundaries and plates and stuff like that, you actually can also emit quite a lot of stuff, right? I mean, one of the most well-known stuff about volcanic eruption is actually not sulfur. It's the amount of water vapor that actually does get introduced into the atmosphere, right? And those stuff are all very difficult to quantify because each of the volcano has its own distinct feature. This is perhaps can also explain why there are so many varieties in terms of the volcanic output. the famous one from Mount Tambora in April of 1815, clearly produced this effect in the northern hemisphere, where we have winter, year without summer, right? In New England, for example. I mean, those phenomenon, I would venture to say, is really related to the solar activity. That falls into a period called the Dalton Minimum, another famous period of minima, basically from, I would say, 1790 to 1820. It's much shorter duration, this one, right? Notice it's much shorter, 30-year period. But the activity phenomenon is documented in sunspot. Now we have direct observation, at least some information. And then we can also document that, all of that in all of this solar activity proxy, as I mentioned, either carbon-14 3 rings or beryllium-10, and we can see that thing in there. Okay, and one of the things that I realized is that it's perhaps related to something even more exotic. People claim Mount Tambora. Mount Tambora, clearly it's not the sun doing that, isn't it? But I realized that it's related to something even more complex dynamics between how all the different planets is actually affecting the movement of the sun within the barycentric center of the solar system. So the notion that the sun is the center of the solar system is not true, right? Because the center is always moving around. Okay, actually, the amount of a region of its moving is quite large. It's of the order of a few million kilometers. So you can imagine why this is not a trivial kind of answer. If it moved by 1 inch, okay, God, we don't have to say it's essentially standing still. But it's not by 1 inch. It's by millions of kilometers. Even the Earth and Venus, we are able to pull and push the sun by about 1600 kilometers in terms of its movement. So it's not trivial. These are all the effects I essentially have to quantify. And the whole idea is that I try to explain that we try to explain how the sun intrinsic variation caused by a dynamo wave. So with another colleagues of mine that is very, very smart from Argentina, we've been trying to incorporate a physics to this problem to see how is it that all these orbital effects could try to affect how the operation of the helical flow. Actually, we only model the helical flow because that's the best way in which best hope in which that we think all this gravitational effect would be able to impact, because it's on a smaller scale, right? It's a bit like a tidal effect, but it's not really tidal. Tidal effect is too small. And to affect the motion, then ultimately it feedback and then cause how the magnetic dynamo is being generated. And therefore, it feedback into the climate system, where during cold time you can imagine that you have more, maybe even more water loading on the thing, so it will be related to tectonic response. That's a complete picture, but it's a hard problem. It's a hard problem because we don't have enough information. But I'm confident though, with this new sketch of work, it's not even a theory because again, it's not yet ready. But the whole idea is that to try to understand the whole system as a whole, my emphasis is always about a picture, a framework in which you can initiate some detailed study to try to go about refuting yourself in a way that is very healthy, that you can learn something from the mistake, even if you find a mistake, right? If it's true, so be it, right? So that's the kind of work that I think will be ultimately very rich and rewarding in terms of trying to gain some understanding of how the whole thing works.